Right. Last question. Last question. All right. Question 24. A hiker shouts towards a cliff as shown in figure 11. The echo is heard 2.75 seconds later. So she shouts in towards an echo and she hears her voice or she hears the echo back after 2.75 seconds. What is the speed of sound of the hiker voice in the air? So first of all, he wants me to find the speed of the sound wave in air. Remember that speed is equal to distance divided by time. Now you might ask me, why didn't you choose the other equation, lambda f? Well, till now I don't have lambda and I don't have f. Let's see what I have, by the way. Here you can see that I have the time it takes to cross the distance. I have t, and I have the distance that the wave has traveled. You can see that the wave has traveled 465 meters from her mouth to the cliff, and then another 465 meters back from the cliff to her ear. So the total distance that the wave has traveled is 465 plus 465, or you can say like 465 by 2 if you're confident with that. So the total distance that the wave has traveled is, oh, I can't see, it's too dark, 930 meters. So the sound wave traveled 930 meters in 2.75 seconds. So you can say I have the time it takes to travel a distance and a distance. This is a suitable equation to find the speed. Speed equals distance over time. Right, the distance is 390 meters over the time is 2.75. Divided by 2.75, that gives you a 338. 338.1218, let's say 2 meters per second. Very good, see? And it's a very common speed for sound wave. It's always in the range of 330 to 340 and something like that. All right, B. What is, oh, sorry. If the wavelength of the sound wave is 0.75, so he gave me another piece of information. He says that the wavelength lambda is 0.75 meters. And then he asks me, what is the frequency? Oh my god, I need the triangle now. Oh, there is the triangle. V equals to lambda f. There you go. I need lambda. I need the wavelength. So you can see to find the wavelength, I need to divide the velocity over the frequency. Right. No, sorry. I'm sorry. He gave me the wavelength and he wants the frequency. So if I want the frequency, then I need to divide the speed over the wavelength. Right, so frequency equals, remember, what is the frequency? So he's asking for frequency. I need to divide the speed over lambda, the speed over the wavelength. Speed over wavelength. Now, where's the speed? I calculated the speed in A, okay? So it's 338.2 divided by the wavelength, which is 0.75. On the calculator, that will give you, oh, I can't see, 450.9. 450.9 hertz. There you go. There you go. C. Oh, oops. Let's find C now. What is the period of the wave? Ah, oh, what a simple question. I know that the relationship between period and frequency is reciprocal. That means one is the opposite of the other. So if he wants me to find the period, I say that's very easy. It's equal to the reciprocal of the frequency. معكوس التردد. T equals to 1 over F. Do I have F? Yes, I just calculated this in B. See, there it is. So 450.9. There you go. So let's divide 1 over answer. Why, I can't see. It's too dark. Okay, equals 2. Let's turn on the lights. Okay, 2.2. That's it. 2.2. times 10 to the power of negative 3 seconds. There you go. There you go. Okay, so this is the period, which is the time it takes a complete the time it takes to make the sound to make one complete cycle. But here you can say that. Now, two notes. The small t is not the same as the big T. The small t is the time that takes, or the time it takes the wave to travel a certain distance. While the big T is called a period. It's the time it takes to make a full wave. Okay, so these are two different things. Alright, I think that's the most important note. Thank you so much, and bye bye.